Hello, my name is Pi, and today I'm going to talk about some numerical methods that I used for my toolbox. So let's start with something that we did in the past. Let's look at the control problem formulation. So here's the Boltzmann form. We have the cost function equal to integral from 0 to capital T of this Lagrange term plus the Mayer's term, which is the term that evaluate at the end of time capital T. Okay, so together we have this Boltzmann form, and this is the cost function. It's just the cost function only. Now the problem is to figure out what's the best U such that it minimizes cost function subject to multiple constraints like dynamic constraint, path constraint, and terminal constraint. Of course, the initial condition is very important. You should know your initial condition at time 0 that is equal to some numbers. Without this, you cannot use it in my program. So you need to know some initial states. For example, robot's initial state, your current revenue or your initial revenue, or depends on whatever you want to use for your problem. Okay, let's start with this numerical method. Okay, it's called direct single shooting. Before going to the details, I'm going to talk about some parameterization you need to do. So the idea is that you discretize the formulation and then you solve the discretized problem. Okay, using numerical tools existed in MATLAB. So you have this control trajectory UT. You have to change or discretize so that you get this capital U. Okay, it's basically a bunch of is you evaluated at different time step. Okay, not different time step, at different time. Okay, and each different time is different by a time step delta t. So this one be 2 delta t, this one be u 3 delta t, and so on up to u of capital T or whatever. Okay, this probably be minus delta t. I'm not sure about the last constraint, but the total dimension should be the size of m multiplied by the number of the sample that we want to discretize. Okay, so this n, okay, depends on, let's say that this is the control trajectory. Okay, is the x-axis or time. Okay, this u axis, u of t. Okay, start from 0 to capital T here. Okay, and you want to discretize at each point. So you take this point, you take this point, you take this point, and so on. Okay, and you have n of them. Okay, n samples. Should be able to know what's the size of the controls input and the number of the samples. Now what you do is that you try to simulate discretize x correspond, so you will get capital X, which is the corresponding state trajectory. Okay, depend on you. So how can you simulate this? Okay, so use some integration method based on the initial condition xu. So it will be some integration method that depends on x0, which is initial condition, and a bunch of control input u. Okay, sometimes it depends on time vector, you might need that. Then you simulate x. Okay, you don't have to do this because it is done in the code, and the part of the code is called forward simulation. All you have to do is to figure out what's the u, okay, or you can come up with a guess of u, and according to based on given initial condition, you should be able to integrate up to x, and it should return not just a single x, but this one is a bunch of a vector x that correspond to different u at different time. Okay, so that's the idea. So now that you get u, now that you have capital X, you should be able to plug it back, and now the problem J will depends on capital U, and I'll use tilde because it's the discretized one, and all you have to do is you want to minimize U. Okay, very simple. So what you do is that you can use a function like fmin_con. That's what I use, or you can write your own fmin_con. I mean, it's the optimization function. Okay, that will take in j tilde, okay, and some initial guess u0, some initial guess, and basically based on this initial guess u0, it will fetch all the numbers, and use they use different method. You can use SQP, you can use trust region method in order to obtain u star. Okay, so this is the idea. I know it might be your first time, very confusing, but this is just a rough idea, so you know how to formulate controls, a discretized control problem based on this code. This is the direct single shooting. It's not the best way to describe it, but you should be able to understand this part, that instead of having the continuous control trajectory, you discretize, it makes it a long vector. So basically you turn an optimal controls formulation to a simple parameter optimization problem. Okay, thank you for watching, and the next video probably going to be me writing some code and tell you, and use the previous example to show you how to solve an optimal control problem. Thank you for watching, and keep in touch.